All right, continuing on with the week 2 notes, we left off on question 68. 68 is very similar setup to 66 and 67, so if you took a little pause between the videos, this will jump you right back in. So we left off with the distributive property in equations. The distributive property looks like so, where you have a number multiplied by multiple terms. So you have to distribute that number that's being multiplied through to all of the terms that follow in the parentheses. Now, anytime you have the distributive property, you want to do that first. So you're going to start by distributing that 2 through to both of the numbers in the parentheses to follow. 2 times y is 2y, and 2 times negative 9 is going to be a negative 18, and that's equal to 40. You really want to be careful with those negatives. If you didn't see those negatives and you got a plus sign there, your whole answer would be wonky. Okay, we're in that basic form where I'm trying to get y by itself. You always get rid of what's being added or subtracted first. So to undo minus 18, I am going to add 18 to both sides so that the negative 18 and positive 18 cancel. My 2y is all that's left over there, so that comes down. So does my equal sign, and 40 plus 18 is 58. Now, to get y by itself, you have to undo the times 2 by doing the opposite, which is dividing by 2. So those 2's go away, and I get y is equal to 58 divided by 2, which is 29 as your final answer. Now, clearly they get a little bit tougher in the next couple of examples. So for 69, notice there is definitely there's definitely distribution to be done in this problem. Look at what needs to be distributed, though. Be very careful. If you look at the last 3 examples, it's just the number directly in front of the parentheses that gets distributed through. So if you look at this example, the number in front of the parentheses is a negative 3. That's all that's going to be distributed through to the 2 terms to follow. Not this 2x. That has nothing to do with it. It's there to just challenge you a little bit. So you're going to bring that 2x down. It's not going to get distributed. Then negative 3 times 2x, when I start my distribution, will get me negative 6, and the x comes down. And then be careful with this one. Negative 3 times negative 3 is a positive 9. Negative times a negative is always a positive. Bring down that plus 4 and bring down the equals 33. Now, if you notice, the last 3 examples we did with the distributive property, after we distributed, they were immediately in that basic form. This one is not. So if you look, there's 2 x's here on the same side of the equal sign, so I can simply combine them. 2x minus 6x is a negative 4x. Now, I can also combine these numbers, a positive 9 and a positive 4. When I combine them, will get me a plus 13. And then the equals 33 comes down, and notice now I'm in that basic form. So sometimes it takes a little bit more. This one was distributing and combining like terms. So we're in that basic form. I have to get rid of what's being added or subtracted first. In this case, that's the plus 13. So I'm going to subtract 13 from both sides. The negative 4x comes down, the equals comes down, and when you subtract 13 from 33, you get 20. Now that negative 4 is being multiplied by x, so I divide both sides by negative 4 so that those will cancel out. Remember, if it's being multiplied by a negative 4, you divide by a negative 4 to keep that cancel. It has to be identical. Okay, and then I end up with x equals, and 20 divided by negative 4 gets me a negative 5 as my final answer. And this next one's kind of challenging as well. Just be careful to see what's being distributed and where. The first one is a little bit easier to see. The 3 is being distributed until the parentheses end, which is right here. So it stops being distributed right there at the 2. So 3 times 2x is 6x, and 3 times 2 is a plus 6. Then the number in front of this set of parentheses is a negative 4. Make sure you include that negative. You will see a question like this on a future test and or quiz, so definitely get in the hang of this. Never drop that negative, just like the negative was in this last one as well. So that negative 4 gets distributed through. Negative 4 times x is just going to be a negative 4x. And negative 4 times negative 5 is going to be a positive 20. and that's equal to 18. Now, a lot like the last one, I'm not in the standard basic form yet, so what I have to do is combine like terms to get there. I have two x terms, a 6x and a negative 4x. When I combine those, I get positive 2x. I can also combine my numbers. A positive 6 and a positive 20 is going to be plus 26, and that's equal to 18. Now I'm in that basic form. So I'm going to follow that same method we've been following all along. Get rid of what's being added or subtracted to the x first. That would be a plus 26, so I'm going to subtract 26. Always do the opposite. See how this is starting to get repetitive and kind of annoying? I keep saying the same thing over and over and over again. It's the same process over and over and over again. So that 2x comes down. 18 minus 26 is a negative 8. Remember, use your calculator when you need to. X is being multiplied by 2, so I divide both sides by 2 to undo that multiplication, and I get that x equals negative 4. Okay, just a reminder, you should always check. I will never in the direction say you need to. I will never take off points if you don't, but you should always check. All right, moving right along. These down here are going to be the toughest kinds of equations you are going to have. So I want to jump back to this last example real quick before we get into this. In this last example, you noticed in this step right here, I'm just going to rewrite it off to the side. We had a 6x plus 6 minus 4x plus 20 equals 18. So we've had a couple of examples like this where you have to combine like terms. So we had the 6x and the minus 4x, and you combined them. The reason that they were allowed to be combined is because they're on the same side of the equal sign. And same thing with these numbers. I can just add them together because they're on the same side of the equal sign. You would never see anybody adding this 20 to this 18 because they're on opposite sides. It doesn't make sense to combine them. So that's what we're going to start seeing in these next few examples. So we're solving equations with variables on both sides. So again, we have problems with two x's in the same problem. But for these ones, if you look at the first example, number 71, it says 75 minus 6x equals 4x minus 15. If I draw this line like I've been trying to draw to help you the whole time, and I look at where my x's are, I can't combine them. They're on opposite sides of the scale. You can't just add the left side of the scale to the right side of the scale. That doesn't make any sense. So what you're going to have to do right here, it says first you must get the variables on the same side by doing the opposite operation. When they're on opposite, it's kind of a nice shortcut, or a nice way of thinking about it. Sorry, there's fireworks going off outside and it threw me off. Anyway, a nice way to think about doing the opposite operation to get something to the other side is when you have things on opposite sides. Like if you notice you have your x's on opposite sides of the equal sign, you have to do the opposite operation to get them to the same side. That's just the way that it works. So if I look at this right here, I have a negative 6x and a positive 4x. It does not matter which one you decide to move to the other side. I have a little hint right here for you that moving the smaller variable will always keep numbers positive. So if you're the kind of person that's afraid of negatives, you would want to move the smaller of the two over, but you won't be wrong if you do it the other way. This first example, I'm actually going to show you both ways. Okay, so first I'm going to show you with my hint moving the smaller variable. So I have a negative 6 compared to a positive 4. The negative's always going to be the smaller of the two. So to move a negative 6x to the other side, I'm going to add 6x to both sides. Sorry about that. So to get rid of that negative 6x, I'm going to do the opposite of minus and add 6x to both sides. So these are going to completely cancel out because they're opposites of each other. A negative 6x, when I add 6x to it, will completely cancel out. So I have 75 remaining on the left side, My equal sign comes down, and 4x plus 6x is 10x, and my minus 15 comes down. If you notice, after I've combined these two like terms in the way that I used this opposite operation, I now have the basic form of an equation. To get x by itself, you get rid of what's being added or subtracted first. So I'm going to add that minus 15 to the other side, because I always do the opposite to move it to the opposite side. Just a nice little way to remember that. 75 plus 15 is going to get me 90, and that's equal to the 10x I bring down. To get the x by itself, it's being multiplied by 10, so I divide both sides by 10, and I get that 9 is equal to x, or in other words, x is equal to 9. Okay, so that's my hint to you. To move the smaller variable over, notice by moving that plus 6 to the other side, I ended up with a positive 10 here. If you don't like negatives, that might be a nice shortcut for you. What I'm going to do is I'm going to get rid of all of this and show you another shortcut. Not really a shortcut, but a hint, I guess, if you prefer something else. So if you're not afraid of negatives, but you like your x to be on the left side, you're always going to want to move your x to the left side no matter what, whether it's bigger, smaller, you end up with a positive or a negative, it won't matter, but you'll still end up with the same answer. Okay, so again, last time we moved the negative 6 to this side by adding 6. This time I'm going to move this positive 4x over here by doing the opposite. The opposite of a positive 4x is going to be subtracting 4x. So if you notice, 4x minus 4x is going to completely cancel because you're subtracting it from itself, but what you do to one side, you have to do to the other. So I have 75. When I combine these two on this side, I get a negative 10x. My equal sign comes down, and I'm left with a negative 15 on the right side. So very similar. We have much more negatives, though, that's for sure. But it is in that basic form, and the x is on the left side this time. So if I'm trying to get x by itself, I have to get rid of what's being added or subtracted first. It's being multiplied by a negative 10, but the 75 can get rid of first. It needs to. It's the one that's being added or subtracted to the 10x. So what's tough about this setup is this is actually a positive 75. So to undo or cancel out that positive 75, I need to subtract 75 from both sides. See how that works over here with the positive 75 minus 75, they'll end up canceling. So we end up with negative 10x coming down, and then negative 15 minus 75 is going to be a negative 90. Okay, almost done. Trying to get that x by itself. It's being multiplied by negative 10, so I divide both sides by negative 10. You have to divide by that negative to make the negative cancel, and then x equals 9 anyway. So see how there's a lot more negatives involved, but you might be more comfortable with the x on the left side. There's two different ways of working with it. I'm going to tell you that I'm going to continue moving the smaller variable every time. So if that's something you'd like to get in the habit of, just follow along with me, but you're always more than welcome during these videos to try it your own way and then just double check to see if it works by checking your answer with us or with me. All right, so the next one we're going to do is 72. Same kind of setup as the last one, where my equal sign is between my two x terms. So I have one of my x terms here and one of my x terms here. I'm, like I said, going to move the smaller of the two between a positive 3x and a positive 6x. 3x is definitely smaller, so to move positive 3x to the other side, I'm going to do the opposite of positive 3, which is minus 3x. And notice when I move it over, I place it underneath the other x term because they're ultimately going to be combined. So these will cancel. 6x minus 3x is 3x, and I bring down the minus 4, I bring down the equals, and I bring down the 2. To get x by itself, you always get rid of what's being added or subtracted first. I know I'm getting annoying by how often I keep saying that, but it's never going to leave your brain. Okay, so I get rid of that minus 4 by adding 4. Those will cancel. I bring down the 3x, I bring down the equals, and 2 plus 4 is 6. All right, my last step to get x by itself is to get rid of that times 3 by doing the opposite and dividing both sides by 3, and I end up with x equals 2. And these ones can be checked as well by just plugging in 2 for x on both sides. You have to plug it in everywhere you see the variable. All right, so the next one, same kind of setup. I know it's a little annoying, but remember, math is practice. The more you do it, the better of a hang of it you'll get, if that makes sense. So I have 4W and 6W, and they're on opposite sides of my equal sign. Remember, if they're on the same side, you just combine them. But when they're on opposite sides, you have to do the opposite operation to get them on the same side. Okay, so I'm going to continue moving the smaller of the two. So the smaller between 4 and 6 is 4. So I'm going to move this term over. It's a positive 4W, so to undo that, I'm going to subtract 4W from both sides. And again, on the right side, notice that I put it underneath the 6W so that I can ultimately combine them. Okay, so 4W minus 4W will cancel, and I'm just left with an 8. It's a positive 8, so you don't have to bring down that plus sign. The equal sign comes down. When I combine these, 6W minus 4W is just a positive 2W. And I bring down the minus 4. Okay, I'm in that basic form. Even though they're flip-flopped, I'm still in that basic form. If you don't like that they're flip-flopped, watch how this works real quick. 2W minus 4 equals 8. That way you can have it the right way with the W on the left side. It's not really the right way, but the more normal way, I guess, like the way you're used to seeing it, and you can have positives. It's like the best of both worlds. Okay, but this is that basic form. To get W by itself, you get rid of what's being added or subtracted first. Stop saying that, it's annoying. I know, I just can't help it. So to undo that minus 4, I'm going to add 4 to both sides so that those cancel out. The 2W comes down, the equals comes down, and 8 plus 4 gets me 12. And then my last step here to get W by itself, since it's being multiplied by 2, I do the opposite and divide by 2, and I get that W is equal to 6 as my final answer. Okay, I want you to pause your video and give 74 a try on your own. Hopefully you are coming back to go over 74. Before we do, I want to give you the code word for this video before I forget. The code word for this video, keeping to that buffalo theme, is going to be sabers. Your code word for the week 2 notes, part 2, is going to be sabers. Okay, so now going over this question that you just tried on your own, the answer should be x equals 1. So fingers crossed that you got that. If not, we're going to go over it together now. So across that equal sign, I'm going to move the smaller of the two numbers over. In this case, this x has an imaginary 1 in front of it. So this is definitely a tougher one for me to give you on your own, but I hope you were able to manage. When there's no number in front, there's an imaginary 1. So between the 1x and the negative 2x, the negative 2x is definitely smaller. So to move the negative 2x to the other side, I'm going to do the opposite, which is going to be plus 2x plus 2x. And again, you do it to both sides to maintain that equality. So these are going to cancel. Negative 2x plus 2x are opposites of each other, so they completely cancel out. On the left side, 1x plus 2x is going to get me 3x. I bring down the minus 6, I bring down the equals, and make sure you bring down this whole term as a negative 3. And then you're in that basic form. So to get x by itself, oh, she's going to say it again, get rid of what's being added or subtracted first. So to undo the minus 6, I'm going to add 6 to both sides. So these will cancel out and leave me with a 3x and equals. And on the right side, I combine these together, which will get me a positive 3. And then my last step here is just going to be to get rid of this times 3 by dividing both sides by 3, and I get x equals 1. So something I'd like to show you just while we are here, and I keep saying it over and over again. Here's why I keep saying it over and over again. You have to get rid of what's being added or subtracted first, because if you choose to divide both sides by 3, it's not going to hold its equality because you're not dividing this by 3 also. You can divide all of them by 3 and then get rid of the adding and subtracting, but oftentimes the this isn't going to mathematically work out nicely. Like maybe this ends up being a 5, and 5 divided by 3, you get a decimal, and then it gets ugly, and it's just not worth it. What works every single time is what I generally tend to show you throughout all of these notes, is the thing that works all the time, and that's going to be getting rid of what's being added or subtracted first. Okay, this next one is a little bit tougher, only because the setup's kind of weird. But here's my equal sign. Notice you have an x term on both sides. I'm going to move the smaller of the two over, which between a 5x and a 7x is going to be the 5x. It is a positive 5x, so to move it to the other side, I'm going to subtract 5x from both sides. So that'll cancel. Positive 5x minus 5x is gone. The 8 comes down, the equals comes down, and 7x minus 5x is a positive 2x. So because there was no other number here, this is technically that basic form, but there's like one less step to do, which is kind of nice. There's nothing being added or subtracted over here to get rid of first. So we just have to get rid of the 2 that's with the x, and they're being multiplied. So to undo it, you divide both sides by 2, and you get that 4 is equal to x, or if you're more comfortable writing it as x equals 4, either way is perfectly fine. Okay, last one for this page. There are a few more on the next page. I have the same setup. Again, I know it's a little annoying, but practice makes perfect. I have a 2x on the left side, 4x on the right side. I'm going to continue moving the smaller of them, which is the 2x. It is a positive 2x, so I'm going to subtract 2x from both sides. Notice, when you're originally given this equation, there's 2 x's and it's impossible to solve for. That's why you have to move it to the other side and combine your x's so that you end up with only 1. Because in this next step, look, when I combine, 7 comes down, 4x minus 2x gets me 2x, and the minus 7 comes down, and now all of a sudden I only have 1x to solve for. That's the whole purpose of doing the opposite operation, to move your other x term over. Okay, now to get x by itself, you get rid of what's being added or subtracted first. In this case, that's going to be this minus 7. To undo minus 7, I'm going to add that 7 to both sides. The negative 7 plus 7 will cancel each other out. On the left side, when I add these together, I get 14 equals a positive 2x. Be very careful. A lot of people end up canceling these as well. Those don't cancel because they're both positive. These canceled because it had the negative here. If they're both positive, they definitely don't cancel. Okay, and then 2 is being multiplied by x, so to get rid of it, I divide both sides by 2, and I get that x is equal to 7. Lots of 7s. All right, a few more questions on the next page. It's going to kind of combine everything we've done so far, like in the whole course. So solving equations using function notation. So remember that f of x, g of x idea, and substitution. So it says in the directions, given that f of x is equal to 2x plus 5, and g of x is equal to 3x minus 1, solve the following. Okay, so I know that f of x is equal to 2x plus 5, and g of x is equal to 3x minus 1. If you look at question 77, it says f of x plus g of x is equal to 19. If you tried to solve this by just like combining like terms and like moving stuff over, like you have too many letters here. What is g? What is f? It's just too much nonsense. What you need to do to start this problem is use that substitution. That we talked about in the beginning of the week 1 notes. We even did it in the beginning of today as well. Okay, but substitution is just another way of saying plugging in. So in place of f of x right here, you're going to plug in what f of x is. F of x is technically 2x plus 5. It told me so in the directions. Okay, I'm going to bring down this plus sign so I have the right format, but then I have g of x. G of x, it tells me in the directions, is 3x minus 1. So I'm going to substitute that in place of g of x, and I'm going to bring down the equals 19. Now before, you had f of x and g of x, something that was completely unsolvable. Now you have something that you can solve because it's got variables to solve for and numbers to work with. Okay, so here's my equal sign. I have two x's again. I have a 2x and a plus 3x. But notice, this one's different than the last 6 examples we did on the last page because the variables are on the same side. What do we do when the variables are on the same side? Yeah, let's go into the first video for this week 2 notes. You just combine your like terms when they're on the same side. So 2x plus 3x is 5x. No doing the opposite or anything. I've seen oftentimes a lot of people end up making this mistake. Okay, the problem with that is they're not on opposite sides, so you don't do opposite operations. Yeah, this will cancel, and you could combine those, but what you're doing here, if you think about your balance beam, oh boy, I'm going to try and draw one here. That's pretty, isn't it? If you subtract 2 from the left side, that's minus 2 over here, and then you subtract 2 from the left side again, this is going to be way higher, and this is going to be way lower. They're not going to be equal anymore. So that is a big, big no-no. It's probably the biggest mistake people make when solving equations. They try to just subtract something from the same side. You can't do that. If they're on the same side, you just add them together. 2x plus 3x is 5x. And I can also add these numbers together because they're on the same side. 5 minus 1 is a plus 4. And that is equal to 19, and we are in that basic form instantly. It's so nice when we get back to that. So to get x by itself, you get rid of what's being added or subtracted first. So to undo the plus 4, you subtract 4 from both sides. The 5x comes down, the equals comes down, and 19 minus 4 is going to be a 15. Almost done. X is being multiplied by 5, so you just divide both sides by 5 so that those will cancel out, and you get x is equal to 3. Which you can also check if you plug it into this. You can't really plug it back into your original because f of x and g of x, what even are those? This is technically your original. All right, let's try another one with that f of x, g of x idea. So the next one, 78, says f of x equals g of x. You're still going to start with that same concept of substituting those in. So where I see f of x, which is right here, I'm going to plug in 2x plus 5. So 2x plus 5 goes here. This equal sign isn't part of substituting, so I'm just going to bring it down. And then g of x, which was 3x minus 1, is going to get substituted in right here for g of x. Now, even though we plugged in f of x and g of x just like we did in the last example, this one is set up differently because of where the equal sign lies. So I still have 2x terms, but notice where they are. They're on opposite sides of the equal sign. When they are on opposite sides, you have to do opposite operations to get them to the same side. So I'm going to continue moving the smaller between 2x and 3x. 2x is definitely smaller, and it's a positive 2x. So to move it to the other side, I'm going to do the opposite of positive 2x, which is a negative or a minus 2x. And what you do to one side, you have to do to the other. So those end up canceling. A positive 2x minus 2x completely cancel. The 5 comes down, the equals comes down. When I combine these, 3x minus 2x is a 1x or just x, and I bring down the minus 1. Okay, we're in that basic form now, so get rid of what's being added or subtracted to the x first. That's going to be that minus 1. So I'm going to add the 1 to both sides so that those will cancel out. And you're actually done at this point. 6 is equal to x, or x is equal to 6. And you're done because there's no number in front of this x to divide by. But we're definitely going to end on a challenging note. This one's kind of a doozy. But we're going to still start by substituting in just like we did with the last 2 examples. But this one you start by plugging in g of x first. So be very careful you're plugging in the correct thing where it goes. So g of x is 3x minus 1. I'm going to plug that in first. I'm going to bring down this minus sign because it's just part of the original given problem. And then I'm going to plug in f of x, which was 2x plus 5. And then I bring down the equals 11. So here's why this one is a bit of a doozy. Okay, you are subtracting f of x. So if you look right here, whoa, sorry, it zoomed in on me. Whoops. You're subtracting all of f of x. The whole thing is being subtracted. So you're not only subtracting 2x, you're subtracting the whole thing. So what I mean by that, it's almost like the distributive property in a way. You're subtracting every portion of f of x. So there's two ways to look at it. The first way is using the distributive property. If you're subtracting the whole thing, you need to distribute that minus sign through. So you end up with 3x minus 1 minus 2x minus 5 equals 11. The other way to think about it, if you don't want to look at it with the distribution property, is just think about what you're subtracting. You're subtracting everything in f of x, which means this is a minus and this is a minus, and ultimately you end up with the same thing. But if you don't have the minus with that 5, the whole answer is going to be wrong. And again, the reason you have that minus with the 5 is because you are subtracting all of f of x, everything that it contains, and it contains the 2x and it contains the 5. So the minus sign belongs to everything in f of x. Okay, that's why it's a doozy. Now we're on to just solving it like regular. So here's my equal sign. I notice that I have two x's again, but they are on the same side of the equal sign. They're both on the left, so I can just combine like terms. So 3x minus 2x is just 1x. I'm just going to put an x. And then I can also combine the numbers. Negative 1 minus 5 is going to be a negative 6. My equal sign comes down, and so does the 11. And that just got so much easier. So to get x by itself, you want to get rid of what's being added or subtracted first. So I'm going to undo that minus 6 by adding 6 to both sides. Negative 6 and positive 6 will cancel. The x comes down, the equals comes down, and 11 plus 6 is 17. So your final answer is 17. If you got tripped up with this part, I will reassure you right now that you will not see anything like that on a test or a quiz. There will definitely be one question like that on the homework assignment as just another practice to kind of go over everything from the notes, but you won't be seeing any tricks like that on quizzes and tests. And I don't really like to throw tricks on quizzes and tests because I don't like throwing you off. I just like seeing that you understand what's going on and you understand the process. Throwing tricks your way is just not fair. Okay, so you will not see something like this, like 79, on a test or a quiz. The other two are fair game. There were no tricks in those ones.